My name is Tom Thompson, and I will discuss aircraft fire extinguishing systems. According to the FAA, these systems dilute the atmosphere with an inert agent that does not support combustion. Hopefully, they eliminate the need for these firefighters practicing at a training facility. The areas that require fire extinguisher systems include engine compartments, auxiliary power unit compartments, cargo and baggage compartments, and lavatories. For the most part, these areas cannot be visually inspected by the crew in flight. Fire, smoke, and heat detectors warn the crew when there is a danger. To extinguish aircraft engine fires, the crew normally pulls a T-handle, which shuts off fuel, electrical, and pneumatic support to the engine. This also activates the release of the extinguishing agent. Boeing 737 fire handles are shown here in the center console. The Boeing 747 diagram here shows each wing engine has a fire bottle, but it can also assist the other engine. For instance, the bottle for number 1 engine is activated to suppress a fire. If the fire is not put out, the bottle for the number 2 engine is designed to extinguish the number 1 engine if selected. Most larger aircraft have an auxiliary power unit in the tail of the aircraft. It's a small engine which provides ground power. Its fire protection system is similar to the main engines and can be activated by the ground crew from a nose gear panel. Flight crew are alerted to cargo compartment fires by lights and oral warnings. A cargo compartment fire suppression system usually provides the initial high-rate discharge to knock down the fire and then a continual low volume to keep the air from supporting the fire until landing. A fire in an aircraft lavatory is suppressed by a small fire extinguisher located just above the compartment waste container. It is activated when the temperature rises above a standard setting. Most modern aircraft systems use an agent called halon to dilute the aircraft atmosphere in case of fire. This product is not very toxic and is easy to clean up. However, it is harmful to the Earth's ozone layer and is slowly being replaced by other products. Halon is stored in pressurized metal containers. It's stored as a liquid with a pressurized gas such as nitrogen. The containers require hydrostatic testing every 5 years. Container construction is shown here. The squib is a cartridge which fires to release the agent. An electrical connector to the pressure switch provides a signal to the crew of container condition so they do not need to perform a visual pressure check. All of these subsystems come together to provide overall protection in the compartments and engines of modern aircraft. If a fire does occur in flight, they activate to suppress the fire and provide the crew enough time to find a place to land. This concludes my look at fire protection systems.